drones are increasingly present in fields, forests and rural communities, but their real impact depends on how innovation connects with real needs on the ground. The ICAERUS podcast series explores how this connection is built through research, use cases and collaboration with innovators and end users across Europe. To better understand the potential of drones to solve these real-life challenges, the project launched an extensive open call to fund 20 smaller projects or sub-projects in two distinct categories. The push open call invited technology-driven proposals from drone manufacturers, research teams and SMEs to develop and test new ideas, tools and prototypes based on drones and drone technologies. The pull open call focused on real needs identified by end users in agriculture, forestry and rural communities, encouraging solutions that respond directly to concrete operational and societal challenges. Today, we will be talking with the project leader from the pull open call. I am Dimitra Furkalidou from reframe.food, and in this episode of the ICAERUS podcast series, I am joined by Martina Mandirola from U-AInSPECT, which is one of the teams selected through the ICAERUS Open Calls. Welcome, Martina.
Thank you.
Before starting to talk about U-AInSPECT, can you briefly introduce the company that you work for?
Yes, thank you for this opportunity. The Center Foundation is a no-profit foundation which is based in Italy, in particular in Pavia, that promotes and supports the training and the research in the field of seismic risk mitigation and in particular structural safety. The founders are all Italian public bodies, in particular the National Department of Civil Protection, the CIU University of Pavia, and the National Institute of Geophysics and Volcanology. Let's say we have an important asset of experimental laboratories that thanks to which we are able to simulate seismic events for testing both structural and non-structural elements. We also promote several training programs in collaboration with the University of Pavia, and we also have an internal drone unit supporting the structural infrastructural assessment and also supporting, let's say, the post-emergency activities.
Your introduction, it really helps us understand the broader context of your work and expertise. Building on that experience in structural safety and assessment, I'd like to know, and if we can speak about U-AInSPECT, can you explain it in simple terms for listeners who haven't heard about it? What is the main goal and why it is important in the context of rural infrastructure?
Yes, thank you. The main goal of U-AInSPECT is the development of an operational methodology that uses drones and AI to support the bridge inspection, in particular in rural areas, which are these areas are, let's say, often intrinsically characterized by a limited redundancy in the local transportation routes. And in this scenario, as you can imagine, if a bridge has a problem and, for example, must need to be restricted or closed, the impact of this on people, services, and in general local businesses could be very, very important. And using drones, the inspection teams can, let's say, collect the data, in particular images and videos, while reducing their exposure to risk situation. For example, if you think that working close to active traffic or in difficult to access area. And on the other hand, in addition to this, the use of the AI can help organize and analyzing the visual data, so expert engineers can, let's say, move faster from raw data to a first, let's say, preliminary structural assessment.
That gives us a very clear picture of why this matters, especially for rural communities where infrastructure plays such a crucial role. Let's now look a bit more closely at how this works in practice. U-AInSPECT combines drones with AI-based analysis for inspecting bridges. Can you walk us through how raw imagery from drone flights is processed and transformed into meaningful structural assessment information?
Yes, let's say the workflow of our project has different steps, okay? The first step is the on-site data collection using drones and following operative inspection guidelines. In particular, we collect videos and images. This dataset is, on one hand, processing for automated damage detection using deep learning models. And in particular, in this project, the AI algorithm has been trained in order to detect 4 common damage classes in reinforced concrete shear debris, which are cracking, concrete cover spalling, reinforcement corrosion, and leaching. And the AI-based tool, let's say, is designed in order to be a support system. And this is a very important point because it is intended to filter, let's say, larger volumes of data and provide meaningful information to the human expert without avoiding any form of, let's say, automated decision making. And in parallel, we then use aerial photogrammetry in order to process the images with the goal of create the 3D reconstruction, so the point cloud model of the bridge. All this data, so the collected one and then also the processing one, are then used as input for the step of the bridge attention class assessment carried out according to the Italian technical guideline. And let's say that be aware of the attention class of the bridge is an important support for the bridge manager, the asset manager, in optimizing their, let's say, financial and technical resources, but also in, let's say, defining proper monitoring and maintenance priorities.
Martina, it's so interesting to hear how the technologies support engineers, how they actually work without replacing their expertise. Of course, moving from theory to real-world implementation always brings new challenges. Could you let us know what were the biggest technical challenges that you encountered in developing the operational workflow and how did your team address them?
Yes, let's say the one of the main challenges was, let's say, ensuring consistent and high quality data in operating in a rural, real condition, while on the same moment respecting the flight regulation, because as you know, all flights need to be conducted in compliance with the national and the European rules, and this aspect can in some situation, let's say, limit where and how we could operate. In addition to this aspect, for example, let's say vegetation, surrounding obstacle, and in general safety constraint, especially if you think in an operative scenarios with active traffic on the bridge and so on, all these aspects can reduce, let's say, the visual access also to some parts of the bridge. And so, for example, as also happened during our bridge use case, there were some areas of the bridge which were, let's say, only partially investigated, and it is another issue, as well as, for example, changing light condition that can affect the image quality, or the fact that the presence of reflective elements that you could find on the bridge. These elements could be difficult to reconstruct in a proper way within the 3D model. We try to face all these issues, let's say, putting in place some mitigation. For example, carry out a proper flight planning in advance is an important aspect. Of course, during our use case, we need to repeat some mission when, in particular, the lighting conditions were not optimal. But in general, let me also add that within our operative workflow, we include also a validation step of the results carried out by a human expert, in order, let's say, to make sure that the results coming from the AI analysis as well as the 3D reconstruction are, let's say, consistent.
Martina, thank you very much for sharing your experience and for helping us better understand how drones and AI can support safer and more efficient bridge inspections. Thank you so much.
Thank you for this opportunity.
For those watching or listening, this episode is part of the ICAERUS podcast series where we look at how drones are being assessed and used in real agricultural and rural contexts across Europe. More episodes are available and new episodes are coming soon. Follow ICAERUS on social media or visit the project website to stay informed. Thank you so much for joining us.